Thanks for coming along to today's session. I hope you're keeping well. I'm going to talk a little bit about modular monoliths today and how I think you can use them to make your microservices journey a success going forward. So a quick bit about myself. So I spent about 10 years working as a software consultant. There you go. So yeah, I spent about 10 years working as a software consultant, working across a lot of different teams, lots of different tech stacks and domains along the way. And about a year and a half ago, I joined Codebase as a principal software craftsman. So a quick bit about Codebase. So we are a software consultancy with the sort of the values of extreme programming, XP, and craftsmanship at our core. And our mission really is to kind of promote good practices and good standards of software and technical practices kind of in the wider software industry. And Codebase was kind of essentially born out of the London software craftsmanship community, where like-minded people kind of passionate about building software and building it in the right way kind of came together and sort of generally trying to raise the bar of software across the industry and across the world that we are kind of trying to build software in today. So I guess let's jump into it then. First of all, let's kind of be clear what we mean by monolith. Primarily, we're sort of talking about a software application that is deployed as a single artifact, where the source code generally resides in a single repository, and the application likely exposes several different business capabilities. So, for example, we want to have an application that manages stock levels, perhaps, as well as being able to, say, take payments for customer purchase, and maybe also kind of reporting, providing some kind of reporting capability, perhaps. And in its most simplest form, it might look a little bit like this. So you have an application and a database. I think you've generally kind of all seen something a bit like this kind of in our careers. And there's nothing kind of inherently wrong with this so far. However, the term monolith often seems as a bit of a dirty word in our industry. The reason for this, I think, is that the majority of monoliths are actually quite poorly structured. As a result, they become kind of hard to change because changes must span multiple parts of the code base. And over time, as more and more changes are added to the code base, the complexity of the code base increases. And the monolith then becomes really a real problem for an organization because it becomes harder and harder to then ship new features to customers. So what we really want is we want our software applications to be highly cohesive, but at the same time loosely coupled. Unfortunately, most sort of monolith code bases, they generally kind of fail in both of these cases. And that gives the monolith really kind of a bit of a bad name. So, for example, we want to keep together all those components and those things that tend to change together. But many teams, unfortunately, kind of fall foul of jumbling up, all different sorts of different components and capabilities. So, for example, you might have database access code being made directly alongside user interface components, for example. So quite clear two different use cases there. And I've worked with many teams that have found themselves kind of in this position where they think microservices is going to be able to get them out of this trouble, get them out of this hole that they're in. And that will be the silver bullet for them. Like if they pick microservices, they'll find themselves in a world where they can deploy their software easily and the code will be easy to maintain and read, and it'll be simple to test and deploy and all those good things. And there's quite a nice quote that I like about this from a guy called Simon Brown. He says, if you can't build a well-structured monolith, what makes you think microservices are going to be the answer? This, I think, came from a sort of a reaction to large numbers of software development teams wanting to then adopt a microservices architecture, even though their current systems and their current designs was kind of akin to that kind of big ball of mud we saw earlier on. And so Simon's point here is that microservices, they're not the silver bullet that you might think they are, and you cannot shortcut applying good structure and good design to your code. And furthermore, microservice architectures don't eliminate this complexity. Instead, they shift that complexity from perhaps an application code-based code level to more thinking on infrastructure and coordination, so deployments, monitoring, observability, testing, those sorts of things. And they're often areas that tend to be less well understood by organizations looking to then sort of jump ahead with microservices for the first time. And so Martin Fowler, he often talks about this term of microservices premium around this kind of idea. And so to sort of break this down a little bit more, I think there's essentially sort of two fundamental pieces that I think teams need to be able to go on a successful microservices journey. And for me, they're engineering practices and domain modeling. And it's my belief that a well-structured monolith, a modular monolith, if you will, is the best place to start with that. So what do we really mean by engineering practices? So essentially, we need to embrace a culture of automation to give us the reliability, but also repeatability too. We need to be able to automate how we build our software, how we deploy it, how we build our infrastructure, and so on and so on. So we also need to have a good grasp of what our application is doing when it's running in production, and by having the appropriate observability and monitoring in place to be able to do that. And so all of this really is the sort of the idea painted in this book, so the famous CD book, which is super important. We need to know that deployments, for example, have been done properly. We need to know what an environment looks like at any one point in time, and be able to kind of get that process of building it repeatable. Deployments should be pretty much dull and boring events and or non-events, if you like, because they're done so many times. You have a lot of confidence in them. And these practices, they really lay the foundations, I think, for being able to evolve architectures and respond to change. If we want to eventually evolve towards a sort of microservice architecture, we're going to need to have these things in place. And without them, it'll be very difficult for us to operate and manage microservices in production. The second fundamental pillar, I think, is domain modeling or domain-driven design. This is all about modeling and representing the real world that we're working in code, and writing code in a way that represents the domain and the context that we're trying to represent. This is really important because we start to think about then in terms of modeling business capabilities and rather than technical features. And doing so then kind of allows us to think about isolating change and having modules that are cohesive and loosely coupled. But perhaps a bit more importantly, by modeling our software around business capability, it allows us to then focus on delivering the business value rather than, as I was saying before, technical features, and being able to be having that clear alignment between the technical parts of the organization and the product and the wider business. So we're all speaking the same language, and we will have the same view of kind of what we're trying to build. So going back to this concept of a modular monolith, what do we really mean by that? It's not a new idea by any means, but it's just got a fundamental concept of trying to break down our code bases and our application into more distinct modules or components. And these can then be worked on individually. So each one communicates with another module through sort of well-defined interface boundaries. And of course, we're still talking about, at this point, a single deployable unit, but we do have, I think, two key characteristics here that I think are quite key. The first one being we have functional cohesion, and the second one being well-defined interfaces. And these are things that we are definitely going to need if we're going to adopt microservices in the future. So starting here is going to lay the foundations for us going forward. So where do we start? So I generally think that there's two work streams here that can be followed on the journey. And these are the two fundamental pillars that I talked about previously, of domain modeling and engineering practices. And I think to a degree, this can be done in parallel. Whilst we're working on understanding our domain better and how to model it, we can also work on ensuring that we have the right engineering practices and the maturity around that in place first. But let's take a look perhaps first at the modeling side of things. So I think you can generally break this kind of phase or part of it into 5 distinct steps. Explore, where, as you might expect, spending some time trying to map out and relying on your understanding of the domain you're working in. Decompose, so breaking down that domain into smaller subdomains, ideally modeled around capabilities of the business you're working in. Connect, so mapping out those similar smaller subdomains and how they interact with each other. And then having done that, there's the codify stage. So taking all that learning and analysis so far, and then reflecting that understanding and that modeling in our code base. And then finally, there's the final step of observe. So taking the time to observe how these subdomains play out when they are codified. So we've built something, we think we might understand what the subdomains and the bounded context might be. Let's just take some time to see how this pans out, because chances are you won't get it right first time. And this will be a process where you're going around this loop a couple of times to rinse and repeat and refine their understanding. So let's break down each step a little bit and understand what we might do at each stage here. So for the exploration phase, or explore phase, generally I'd use something like event storming workshops here. So previously, I guess before lockdown hit, you'd have physical walls with physical post-it notes and those sorts of things. But nowadays, it's a bit more remote. So we'd be using some online collaboration to do these sorts of things. But the outputs are generally the same. So if you've not done event storming before, or you've not heard of it, I highly recommend looking into it. I won't go into it in super detail today, but essentially it's a workshop format that allows you to explore business domains in a collaborative way. So the founding father of it, a guy called Alberto Brandolini, he has a really good book on it on Lean Pub too. That's worth a read. And this workshop effectively allows us to map out business processes from the start to finish, and to capture all the different systems and the steps involved and all the different actors along the way. And by doing this exercise, it allows building a really strong alignment for all the different parts of an organization. And that's a really key fundamental building block for us then to start moving towards codifying a solution later on. The next stage then is the decomposition or decompose stage. So once you've been able to map out the processes end to end from our event storming workshops, we can then take that a step further, which is the decompose phase. So we can then analyze the output of that event storming session or sessions, and try to identify logical groupings of behavior, which are then functionally cohesive. And these become good candidates for bounded context, thinking the domain-driven design, domain modeling concept. Or larger, in effect, subdomains, if you like, within a larger domain that we're operating in. And these bounded contexts will ultimately become the various modules that will make up our modular monolith codebase later on. And maybe even further on down the line, these bounded contexts can often be good candidates for microservice boundaries too. There are quite a number of useful resources that the DDD crew have around this space as well that are quite useful, they're quite worth having a look at. that can help you on your journey around some of these sorts of steps. So the first one I quite like is this bounded context canvas. So if we do the bounded context that we've identified through our EventStorming workshops, for example, we can start to kind of fill out this bounded context. So it kind of helps us to clarify things such as what are the main responsibilities, for example, of a particular subdomain that we're trying to analyze. What messages does this subdomain produce and consume? What are the key entities, for example, that this domain will be responsible for? What's the key domain language that will be at play? And how will this domain like fit into the wider organization and the wider different domains that are at play? So by using this, we can start to document how each of these subdomains will start to play together and what they will look like. But also it's kind of a really useful tool, I think, to sort of build alignment within the organization and start to highlight any assumptions that we might have and have those documented and test them later on. The next step then is this sort of connect step. So having identified sort of various subdomains and on the canvas there, the next step is to take that one step further. So we have these ideas of different bounded contexts and different modules. This is all about kind of trying to see what the different messages might be between the different subdomains and mapping out what that would look like. So this technique is called domain message flow modeling. Again, there's some examples there on GitHub on how to do this, but effectively we're taking particular user journeys that we've identified in the very first step with the event storming, and trying to see what sort of data and events that might pass through these different subdomains that we've tried to identify them. So for example, in this case, placing an order when all items are in stock, there's 3 different subdomains there that you've identified as bounded context, and what are some of the commands that might flow between them. So doing so allows us to test out whether our subdomain split actually makes sense. Do we have too much, for example, coupling between the domains? Is a lot of messages kind of flowing back and forth between 2 or 3 domains that are quite chatty? Could that be broken down a bit further, and sort of so on and so on. And you're kind of starting to sort of think about what some of the contracts between these domains might look like too. And then we have the codifier stage. So once you've done that sort of those analysis around the sort of the domain boundaries, and we're quite confident about these domains at this point, we can now sort of get our hands a bit dirty and kind of go into the code base and start to introduce these bounded contexts or subdomains, if you like, into our code. What we're looking for here is to kind of have these bounded contexts and domains as kind of really first-class citizens in our code base. So when we open our code base, we should be able to see them as kind of first-class things. So, for example, if you had a Java code base or any kind of code base really, you should see your bounded context at that sort of top level. So, for example, if you were in a sort of Java or C# world, you could use language constructs like packages and namespaces, for example, to represent these bounded contexts. So here we have the customer and payment domains, and we modeled them in our code base as different packages in this example. And if you want to, you can even sort of go a step further by enforcing these bounded contexts and package namings with unit tests. So in the Java world, there's tools like Arts Unit, for example, that you can kind of document these bounded contexts and modularity, and have that as a running test. And so if someone comes along and breaks that modularity, there should be a failing test that gets triggered and catches that change. So in effect, kind of protecting your modularity. And then finally, having done all of that, we now want to observe how this plays out for a while. It's quite possible that the interface boundaries that we've introduced might not be correct, or require some changing or some tweaking along the way. A good test of this is generally sort of making a change to the code base over time, whether or not you need to add features to more than one boundary, domain boundary, and what that looks like. Are features sort of spanning multiple domains, and kind of how much interference is there going on? And I think this is kind of where the modular monolith becomes really useful, because refactoring subdomains in a single code base is actually quite a straightforward activity task. If you're kind of refactoring module boundaries in a microservices world, that's a lot more costly, because we're then pulling together separate deployable units into one to then kind of realign the boundaries and kind of break them apart again. So that's a much more complex and costly task to do. So I think in the early days, when we're kind of trying to figure out what these domain boundaries look like, and we're testing the correctness of them, having a single code base to work with where refactoring is cheap is a really useful thing to have. The danger, I think, is that we can introduce microservices before our domain boundaries are well understood, and then it does become kind of really costly to change them, and some teams also then try to ignore this fact because it is costly to them then change the boundaries, and they kind of plow ahead, and later on they find themselves in a whole world of pain because they haven't kind of paid back the sort of the domain modeling debt, if you like. And at that point, you end up kind of having lots of coupling between distributed monoliths in effect, which is a really bad place to be. So going back to this kind of sort of second fundamental pillar we talked about earlier on, we talked about domain modeling. The second one is, I guess, engineering practices. It's quite a broad topic, so I guess kind of where do we start here? So I guess kind of I would generally start with an exercise like a value stream map, with a bit more of a focus on the engineering practices side of things. So we want to map out the current process, for example, for how our software gets into production. Right from the beginning, when our developers pick up our user story, to then having those changes running in production and being used by our customers. So from this, we should be able to answer questions such as, how does our software get tested? How do we build and package our application? How does it get deployed? How long does it take to get a build through the deployment process? And how much confidence do we have in that process? And again, this goes back to the concepts of, I guess, continuous delivery, because we want to be able to automate as much of that as we can to ensure the process is repeatable, but also kind of reduce the management overhead of these tasks. If we currently have lots of manual or semi-manual testing going on, for example, and the deployment process becomes quite costly then to sort of then scale that out into a microservices architecture, because the testing overhead and the amount of manual work will be sort of a lot more than it will be with sort of one code base. So it really does kind of pay to have that automated early on, and because that will then scale well going towards a microservices journey later on. It's also worth calling out observability here too. I think I still see quite a lot of teams struggling with this one. I think it's really important that your team are the first people to detect a problem with your software, not your customers or your stakeholders. And so, what does good observability look like? So I think it's about generally being able to understand and explain any state of your system can get itself into, without having to deploy new changes to understand that. So we want to have good and meaningful application logging, for example, and collection of telemetry data. So this might include things, for example, how long it takes for requests to come back from external services, how long our application took to respond to a request, response codes from requests, and so on and so forth. And we can then collect this data for querying later on in the future, or like set up alerting on particular thresholds, for example. So a certain number of requests going over a certain time period threshold, and we get an alert, that kind of idea. So observability in a microservices world is even more paramount because you have multiple deployable units running then, and you might have to then sort of stitch these together to reason about what's going on in a particular journey. So standing up good observability and good monitoring of your modular monolith will stand you in very good stead if you do eventually want to go down the microservices route. But even if you don't decide to go sort of full microservices, I think it's an incredibly useful thing to do anyway. It enables you to ultimately be able to make data-driven decisions about your software and your designs. So all these concepts that we've discussed so far around domain modeling and engineering practices, they're not sort of new ideas as such. However, they are, I think, prerequisites for thinking about a microservices journey. And if you don't have a solid grasp of the domain and bounded context you're operating in, you're going to find it really hard to then kind of identify microservice boundaries later on. And you'll likely get them wrong, which will mean that you'll end up having heavy coupling between services. And this can, in effect, lead to sort of the distributed monolith, which is something to avoid at all costs, really. Without the engineering practices, you'll find it difficult to manage all the moving parts of a microservice architecture. And being able to handle failures and understanding and reasoning about how your services are behaving and so on. And so I think the modular monolith architecture can be super useful in helping us level up in these areas. As we learn more about our domain, making adjustments to bounded context, etc., is a far cheaper exercise to do with a modular monolith single code base than it would be to do across remote service boundaries. With less moving parts, we can focus on making sure we have the right engineering practices. We have the automation of our deployments, our build, our monitoring. We have good logging in place and good observability, so we can understand what our application is doing at any one time. And in truth, I think for many situations, teams may find that a modular monolith actually suits them perfectly fine, and they don't need to then go the next step towards microservices. However, there may be particular reasons why you want to take that next step towards microservices for various business reasons. So I guess let's take a quick look at some of the approaches that you might take to refactor from a modular monolith, say, to then go to microservices. So Michael Feathers in his book discussed the concept of a seam, where a seam is a portion of code that can be treated in isolation, in effect, and as a result can be worked on without impacting the rest of the code base. So Michael's primary usage of the word seam in his book was to help kind of working with legacy code bases and trying to clean them up. However, I think we can use the same concept too when wanting to move towards a modular monolith towards microservices. So having got to the point where we have this modular monolith and we've kind of modeled the bounded context and the domain in our code base, these bounded contexts can act as these seams, if you like, or service boundaries. And so we can start to kind of see already the benefit of having done that sort of domain modeling piece earlier on. So say, for example, we've identified a bounded context that we want to extract out of our modular monolith. There's a few approaches that we can take to allow us to refactor that out into a separate service. It's important to, I think, keep in mind that these are essentially refactoring patterns. So we're not changing any behavior as such here. We are more refactoring or evolving, if you like, our architecture based on some business need. And the key thing as well is that we want to do this in an incremental way, rather than a big bang approach. That means that we wait a long time for any feedback and have a high degree of risk. So these two patterns here, for example, they allow us to do that in an incremental way. But again, they rely on having this modular monolith in place first, where we have the bounded context or the seams, if you like, kind of quite well defined. So the first one I'll talk about quickly is the triangular pattern. If we imagine our modular monolith looks a bit like this, we've now modeled a few different capabilities. We're pretty confident that the domain boundaries that we've modeled here are correct. and now we want to extract out one of them into its own standalone microservice. So with the triangular pattern, what we can do is put kind of a proxy router in front of our modular monolith that can intercept requests and direct the appropriate request to our new microservice. Whilst other traffic then still gets routed to the modular monolith as was before. So in effect, it allows us to incrementally strangle the monolith until such point that the microservice is ready to kind of receive requests. And once we're happy with our microservice extraction, we can get our customers or our clients to now call our microservice directly for that particular capability. That's now handled by our new microservice. And so we're now removing that kind of intermediary proxy. So that's all quite nice and fairly, quite clean. However, that kind of works well for those modules that are at the edge of our modular monolith, if you like, i.e. those requests that can be mapped to HTTP API requests in your code base. But however, there are those modules or capabilities that don't fall into that category, where we can't just intercept existing requests to our modular monolith and use that similar pattern from before. In this situation, we can use a technique called branch by abstraction. It's often used in the context of kind of object-oriented programming, where we want to sort of do something like this to allow us to carry out some sort of parallel change. So let's say, for example, we have a part of our code base that is responsible for sending invoices, say, to customers. And we'd like to refactor kind of how we do that. So, but we don't want to break the existing functionality. So step one would be to kind of pull that particular behavior together in one component. Then second step would then be to introduce an interface on top of that component to act as an abstraction point. Then the third step after that is that you now have the freedom, if you like, to then build a second implementation of that interface alongside the current one. So we can use things like configuration or feature toggles to then decide which implementation we want to wire up at runtime. This is a really useful technique at a code level when working with sort of chunk-based development, for example, as it allows us to do the parallel change to take place. But we can also use this technique if you want to refactor a modular monolith to extract our microservice too. So if you go back to this slide from before, and let's say we want to extract out module D here from our modular monolith. There's no direct incoming request that map to our module D's behavior. So instead, module A currently kind of collaborates with module D internally. So with the branch by abstraction pattern, what we need to do here is once again create an abstraction point over the decision we make to communicate with module D. So once we have that abstraction point, we're initially going to keep it the same as before. So here it's just kind of simply calling a local method within module D. And then we can deploy this code to production and sort of nothing else should change. So we now have this kind of simple client here that's kind of simply kind of passing through as before. Nothing really changed in that regard. Alongside all of that, we can now start to build out a separate microservice for module D's behavior. And the modular monolith kind of remains untouched as is. And we can then kind of start to deploy this microservice to production and manually sending requests to it and testing that it's doing the right thing, all the while our monolith is kind of serving our customers and the behavior is unaffected. And then once we're happy with our microservice, we can then start to introduce a second implementation behind the abstraction point we created in module A before. And this allows us then to make a decision about whether we want to call the microservice or not. And again, we can use things like feature toggles here to decide which of these implementations we want to wire up in production, i.e. whether we want to call our new microservice or whether we want to carry on with the local method call to module D. And then finally, once we're happy with the new module D as a microservice working alongside our modular monolith, we can then kind of remove the code cleanup that we had before and have that kind of back and have that module D completely removed from the modular monolith. I think it's worth talking a bit about the database here too. I think often that's an area that's forgotten a little bit. If you go back to this kind of earlier image of the modular monolith, we're kind of starting to pave the way for extracting out a microservice, but we're kind of missing something a bit from this diagram, and that is, I guess, the database here. So once you start to stand up a microservice, the temptation can be to straight away introduce a database for the microservice. As we all know, that we want to avoid coupling and we want our microservices to own their data. That's all good. But I think as a temporary measure during a sort of a migration phase between modular monolith and microservice, I think it's actually okay to do something a bit like this. It allows us to be confident that the microservice boundary is indeed correct and that we are happy with it running as a separate deployable unit before we refactor the database. However, we do need to kind of make sure that all the while that the database is being shared here by the microservice and the modular monolith, that we haven't yet done the full migration, and there's still work for us to do. But once we're happy then with that, we can then sort of move towards this pattern where module D has its own database separate from the modular monolith as a microservice. And for the data that should be owned by our new microservice, that is all extracted out of the old database, if you like, into a new one, and only accessed by our new microservice. So if our new microservice should have a need to access data from the modular monolith, it would do that via an API call into the modular monolith, not a direct database call anymore. So we're kind of removing that database access and that database coupling at that point. This kind of leaves us in a position where we have now removed the database coupling and our microservice effectively sort of owns its own data, and that can now be deployed independently and all those good things around that. So to wrap up, I guess some key takeaways I want to sort of leave you with today. Microservice architectures, they do require a certain level of maturity. I think namely the two fundamental building blocks of domain-driven design and kind of engineering practices underpinned by continuous delivery. So being able to understand your domain and your software and the world that you're operating in is super important. And these take time to understand. So trying to do that whilst adopting a microservice architecture is going to cause you pain. So instead, reduce the amount of moving parts and the sheer complexity you're having to deal with by, I think, adopting a modular monolith will be a good move for you. This allows you then to focus on getting the fundamental building blocks in place that will ultimately make your journey towards microservices a much smoother one. But of course, if that's something that you want to do, I think, like I was saying before, for many teams, a modular monolith is a perfectly fine kind of ending point. As long as it has great automation and tooling for observability and monitoring and testing, that can be a perfectly fine solution to stick with, unless there's a real business need for you to extract out microservices. But again, kind of having gone through that domain modeling process, if there is a clear need for you to move towards microservices, that should be a much simpler job for you to do because you've already got the domains nicely modeled in your code base already. I guess if you're kind of curious to sort of dig into this a little bit more, there's some really good books around this topic. So these are a few here. There's a lot more out there, but these are sort of 6 of my favorites. I guess a super quick plug, if you're kind of keen on what we've discussed so far today, because we are hiring across both the UK and Spain, so please do get in touch, either on that link on the slide there or kind of grab me on LinkedIn or Twitter.